All right, problem number 5. A 65 kilogram person is standing on a scale in an elevator. What will the scale read in newtons if the elevator is A, moving up at a velocity of 3 meters per second, B, accelerating upward at a rate of 2 meters per second squared, or C, moving downward at 5 meters per second, and option D, accelerating downward at 1.8 meters per second squared. Okay, so here's the really simple and easy rule is remembering the tension force is pointing up and mg for the entire elevator is pointing down, and then the normal force from the scale on the person is pointing up, F normal. Okay, so outside the elevator, tension force, mg, inside the elevator, the normal force, and whatever mg is on the inside of the elevator. So if you're sitting still on the elevator, the mg is pointing down. Remember, the mg on the elevator total is pulling on the tension force. So this and this is the outside. Then internally, there's another little mg of the person on the scale and normal force of the scale pushing back up on the person. Okay, so here's the rule. If the velocity is constant, up or down, the weight is the same as if v is 0. So it's just mg. Normal force equals mg. If the elevator is moving at a constant speed, constant v, mg equals normal, equal. Including v equals 0. Okay, so constant velocity up or down, same as mg, same as if v is 0. So here's a little note. If the acceleration is positive, in other words, upward, we add your acceleration to g, and then multiply by the mass of the entire elevator to get the tension force. Okay, because ultimately, vertical net force is F up minus F down. Well, F up on the big picture is the tension force. F down is mg of the whole elevator, person inside, everything. So the net force then would be up minus down. So whatever the up, if the net force is accelerating upward at 2 meters per second, so A net equals 2 meters per second. That means we can imply we'll rewrite this equation with numbers. The mass of the elevator times 2 meters per second squared is equal to tension force minus mass of the elevator times g. If you look at this, we're going to add mass of the elevator times g to both sides. So then we can factor out mass of the elevator, and we just say 2 plus g. So if A is positive, we add A to g. A plus g times the mass of the elevator would give us the tension force. If A is negative, in other words, accelerating downward, we're going to subtract A from g. So g minus A times m would be your upward pull.